Hi everyone. So this week's experiment is about bending of light, and I just want to show you how to use the simulation in this small video. So when you click on the link that I provided in the lab activity, it opens up here. So you click on more tools, and then this is how it opens up. Basically, with this green arrows showing you the directions, you can basically change the light direction, where you can turn on the light with this big red button. So you have two media here. One is right now air. This box is showing you the material of the first medium, and this box is showing you the second medium. So we have right now a refraction and reflection through air to glass. So there are different tools here that you can use. One of them is speed. You can just put it in this and or carry it to there to look at the speed in that specific medium, or you can calculate the speed yourself. You can click on angles to be able to read the angles with the normal. So this dashed line is basically a hypothetical line that is perpendicular to the boundary between two medium that you have, which is air and glass here, which you can change from this choices that you have: air, water, glass, Mr. A, Mr. B, and custom. Custom you can create by changing the index of refraction, which we will not do. So we either use air to water, water to air, or glass to air and glass to water, things like that. So let's see. So by changing the angle, you're given some angles for the incidence. So incidence is basically the light ray, which is red here, with the normal. So in optics, we always use the angle defined by the light ray itself, incoming light ray, which is incidence, and the surface normal, which is this hypothetical line that is perpendicular to the boundary. So right now my incidence angle is 53.1, and therefore the reflection angle is as well 53.1. As you know, law of reflection states that from a smooth reflective surface, reflection occurs in a way that the angle of incidence is same as the angle of reflection. Therefore, we have 53.1 degree here and 53.1 degree here. And this angle that you see here between the refracted light ray and the normal, surface normal, or in short, we call it normal, which is perpendicular line to the boundary between these two media, is 32.2. So the amount of bending, as you can see, the light is bending while it's traveling in the air. As you know, it's fastest in the air on vacuum, and it slows down in all other transparent medium. So because of that slowdown, it changes direction. It's logically, basically, it comes from the fact that we actually live in a four-dimensional world, not three. We don't really kind of perceive the fourth dimension that much, but because light is velocity of light is either speed of light itself, which is 300,000 kilometers per second, or close to it. Even if it gets into a different transparent medium and slows down, it's still very close to speed of light. So it's basically feeling that four-dimensional universe itself. So shortest distance is not like VC is a direct line between those 2 points. Because of that effect, basically the fourth dimensional effect, we see the bending of light when it enters into another medium. So depending on the refraction of index, which is the ratio between the speed of light in air and speed of light in that transparent medium, in this case, which is glass, we can calculate index of refraction, which is 1.5 for the glass. And when you choose, let's say, another one, which is water, then it's going to be 1.33. And you can see that because the index of refraction is less here, the bending is, you see how much the bending happens with respect to glass. So the glass bends it more, right? Because its index of refraction is more. You pay attention to these details while you're doing this lab activity, and so you can answer the questions in the lab and the homework and the tests. So please take a note to yourself, like what you observe while you're doing this homework and lab, so that you can use your own notes in the last test, and try to get as high as possible so that you can get a higher grade. So as you can see, because the light is fastest in the air and vacuum, it slows down in the second medium here. and it bends towards surface normal, as you can see, whether it's glass or water or any other transparent medium. The amount depends on the material and also with what angle it is being sent, which is the incidence angle. In this case is 53.1, but when I change it, it's going to show me a different angle of refraction, right? So this, how much bending occurs depends on the angle of incidence as well as the refraction index of the two mediums. So it doesn't have to come from air and goes to another medium. It can go from water to air, but also water to glass to air. You can have multiple layers even, but I don't believe we have any such example in the lab or homework. But in any case, relative refraction index is what matters in this bending amount. Therefore, the only really major thing is that if it slows down in the second medium, it bends towards the surface normal. If it gets faster in the second medium, it goes away from the surface normal. The only reason that the light bends towards surface normal, it gets closer to the surface normal, is that because speed in this medium is slower. So it's, you can see that 0.75 c. C is the speed of light in air or vacuum, which is 300,000 kilometers per second. So if you go to air, it's going to show you 1 c. So this ratio basically, which gives you the value of n, which is index of refraction. Okay, so back to glass, you will see speed is different. Also, c is 0.67, and it was 0.75 for the water. Okay, so these are the things that you will need to answer those questions in the lab and the homework. I believe if you play with this a little bit before you do the homework, you will get the hang of it, and I'm pretty sure you will be able to answer all of the questions correctly. So I don't believe I was asking you to use the speed tool in the question, but I mean, apparently you can anyways. But you can also calculate it using the relation for index of refraction, because n is equal to c over v. V is being speed of light in that specific medium, right? Or just use this and calculate what is the real speed in terms of c. C is being 300,000 kilometers per second, or 3 times 10 to the 8 meter per second, depends on the unit. So this is, I believe, will be enough for answering these questions. If you have any other question, please shoot me an email and I will try to help more. Have a good day.